There's a lot that can go wrong during a spacecraft launch. And shortly after Apollo 12 left the ground, the mission was struck with an electrifying complication. Not once, but twice.
I don't know what happened here. We had everything in the world drop out. I'm not sure we can get hit by lightning.
1969 was a milestone year for NASA.
The Eagle has landed.
The space agency achieved its goal of getting to the moon and back by the end of the decade. But Apollo 11 almost didn't make it there. During their descent to the moon, the lunar module threw a fit and the astronauts missed their target landing spot by a good 6 kilometers. So the next mission, Apollo 12, would have to prove that a precision lunar landing was possible. The crew consisted of close friends, Commander Pete Conrad, Command Module Pilot Dick Gordon, and Lunar Module Pilot Al Bean. Aside from perfecting landing techniques, their primary objectives were to perform detailed scientific lunar exploration and deploy the Apollo Lunar Surface Experiments Package, or ALSEP for short. This was a collection of geophysical instruments designed to monitor the environment of each Apollo landing site for the period of at least a year. Conrad and Bean would be the astronauts to put this science into action in the moon's mysterious region known as the Ocean of Storms. On the morning of the launch, ominous clouds blanketed the sky above the Kennedy Space Center. But the rain was dying down and conditions were within the minimums of what was considered adverse. So, Apollo 12 took off.
Liftoff.
About 36 seconds in, things got weird.
The hell was that? I lost a whole bunch of stuff.
The crew didn't realize it, but a powerful electrical surge had shot through the Saturn V. And about 20 seconds later, Mother Nature would prove that lightning can and will strike the same place twice.
Okay, we just lost the platform, gang. I don't know what happened here. We had everything in the world drop out.
The crew was in the dark. Several major systems went offline, including all 3 fuel cells, the spacecraft's main source of power. If they didn't find a solution in the next 90 seconds, Apollo 12 would have to abort. On the ground at the Manned Spacecraft Center in Houston, Mission Control was just as confused. The flight controller consoles were reading nonsensical telemetry data from the spacecraft, giving the team no sign of a solution. This was a nightmare scenario for Flight Director Jerry Griffin. Just over a minute into his first mission as lead flight director, he was facing a potential disaster. But if Griffin learned anything from his mentors, there were a lot of options, and failure wasn't one of them. Throughout the Apollo program, the mission control team was faced with do-or-die decisions. It was by no means a low-stress work environment. Many of the Apollo flight controllers joined NASA with no relevant experience, and some were fresh out of college. But in a very short period of time, they had to become masters of spaceflight. NASA's first flight director, Chris Kraft, was essentially the brainchild of Apollo's mission control system. At the helm of each crewed mission was a flight director. He was supported by a team of flight controllers who were responsible for specific spacecraft functions. For example, Guido watched over the primary guidance, navigation, and control systems, while ECOM handled the electrical, environmental, and communication systems. The Apollo mission control teams ran thousands of flight simulations to anticipate every possible scenario that could unfold in space. And during Apollo 12, a memory from one of these simulations saved the team from an abort.
Apollo 12 Houston, try SCE to auxiliary, over. Try SCE to auxiliary. What the hell is that?
SCE to aux was the answer to their problems, and 24-year-old ECOM John Aaron was the only one who knew it. A year earlier, he was in mission control during a simulation in which the spacecraft's voltage was accidentally dropped. The change affected the Signal Conditioning Equipment, or SCE, which was a small power supply that provided voltage to critical instrumentation points in various systems, including the fuel cells. If the power supply failed, an auxiliary supply could be switched on.
SCE to auxiliary.
All the crew had to do was find the right switch, which wasn't a simple task given the complexity of the spacecraft's display. Astronaut Al Bean was the only member of the crew who knew which switch to flip.
We've had a couple of cardiac arrests down here too, Pete. Man, oh man.
And just like that, the spacecraft systems came back online and the flight controllers were able to read the data again. Rookie flight director Jerry Griffin escaped the near abort. He found no other damage from the lightning strike, so Griffin decided to continue to the moon. The astronauts, still in disbelief, laughed uncontrollably until they reached orbit.
That was something else. I never saw somebody light on the floor so many lights up there I couldn't read them all.
Once settled in lunar orbit, Conrad and Bean embarked on the most crucial part of the mission. They had to perfect a pinpoint landing on the lunar surface. But first, they had to find their targeted touchdown point. As they approached, Conrad recognized a familiar crater from a map of their landing site.
There it is! Son of a gun, right down the middle of the road!
He steadied the lunar module and touched down in a cloud of dust within close range of their target, demonstrating that a precision lunar landing with the Apollo system was possible.
And that may have been a small one for Neil, but that's a long one for me.
Once on the surface, the astronauts conducted several experiments and deployed the ALSEP. They also collected and returned components from the nearby Surveyor 3 spacecraft, which landed on the moon in 1967. After over 30 hours, Conrad and Bean flew back to the command service module, where their buddy Dick Gordon was waiting. Apollo's three best friends splashed down in the Pacific just 62 seconds later than planned. Apollo 12 didn't get as much attention as Apollo 11, in part because it wasn't televised. Shortly after landing on the moon, Bean fried the camera when he pointed it directly at the sun. But all that aside, Apollo 12 turned out to be a pioneering mission for the Apollo program. The pinpoint touchdown of the lunar module enabled all the targeted landings to follow. And the near abort showed the capabilities of mission control, proving that the team was prepared to work through unexpected problems under extreme pressure. And that would become incredibly important for the next mission, Apollo 13. Like Mission Control, the Apollo astronauts went through extensive training, learning how to do a job that had never been done before. If you want to get a look inside their extreme spaceflight preparations, check out our episode about Apollo 11. And if you want more, be sure to watch the entire Apollo series. Thanks for watching.